Now we switch on the machine. For now, we mark the sample according to the size that we want. We open the machine safety cover. For the next process, put the sample at the gripper slot and check the cutting position and put down the cutting blade holder until the cutting blade parallel with the mark on the sample. We move the both gripper forward to grip the sample and lock it up. Now close the safety cover and start the machine. Make sure that the safety locking at the left side of the machine is functioning well. And after the process is complete, now we open the safety lock and we screw it up. We open back the lock and we take the sample that we already cut. We close the machine safety cover and switch off the machine because this is the safety for us. Switch on the machine. Now spray the mold release spray on the ram surface and put the sample on the surface. And next, push and hold the down button to move down the ram. Then put in 1 scoop of phenolic powder in the ram using a funnel. Spray the machine cover with the mold release spray and close the ram until hand tight. Press the run button to start the molding process. Process has been complete. Push and hold the down button to move down the ram. Push the hold the up button to move up the ram and take out the sample from the machine. Before start the grading process, see the sectioning of the sample first. Make sure that the sectioning is perpendicular with the position of the grading process. Then grind the sample one direction in a time with flowing the water continuously. Switch on the machine. Press run or stop button to start rotating the polisher table. Hold the sample and start the polishing process by rub the sample surface on the polishing pad with counterclockwise rotation. After done polishing with all dilution, dry it using the dry air. Switch on the fume hood suction motor and light. Switch on the suction motor and light. Open slightly the fume hood safety cover and etch the sample in the etchant chemical. Open the water valve and rinse the sample equally. Take out the sample after done with the process.
Hi, my name is Lexter Helson and Anthony. Okay, today I would like to present my experiment, that is M1, the effect of heat treatment on the microstructure of steel. This is the result that I get after the process has been done and observed under the optical microscope. Okay, for the discussion, for the first question is, what is the purpose of etching process in the preparation of metallographic sample and how is it done? It is used to reveal particular structural characteristics of a metal that are not evident in the polished condition. The surface of sample is cleaned with alcohol and dry, and then the surface of sample is immersed in the etching reagent for a few seconds, and then the sample is placed under a stream of water to remove all the traces of acid. Then the sample is washed again with alcohol to prevent watermarks, and the sample is ready to be viewed under the microscope, and then we will get the result like before, like this. Okay, and then the next question is, describe the heat treatment procedure for steel. Okay, for the first one is annealing. Annealing is the heat treatment in which a material taken to an elevated temperature keep there for some time and then slowly cool. And the final microstructure is coarser per light. And then normalizing is an annealing heat treatment process accomplished by heating at approximately 55 degrees to 88 degrees above upper critical temperature and followed by air cooling. And for the final microstructure, it is fine perlite, and then quenching process of heating sample to the austenite range and then cooled rapidly, and it is called by martensite for the final microstructure. And lastly is tempering. Tempering is a process of reheating martensite steel at a temperature below the eutectoid temperature, and for the final microstructure it will be called tempered martensite. For the next discussion is, briefly describe the characteristic of martensite microstructure. For the martensite microstructure has a lower density than austenite, so that the martensitic transformation result in a relative change of value. The needle-like microstructure of martensite leads to brittle behavior of the material. Too much martensite leaves steel brittle, too little leaves it soft. And the conclusion is, preparing of metallographic sample for microstructures observation has been understood. The effect of heat treatment on the microstructure of steel has been understood. And then lastly, the microstructure of ferrite, perlite, cementite, austenite and martensite under microscopic view has been understood. So that's all for me.